Well, we've popped it open, and I've already taken the liberty of getting a little bit ahead of the game. What I want to show you is what I found here. This is the front. This is the front, and that's the top side of the circuit board, which you can see is an old style through-hole style board with vias and these foil traces, which we're going to come back to later on. These are not copper traces, these are foil traces, and that's going to be a problem for us. On the underside, it's a mess. You see all this corrosion, this blue stuff. There were 4 AA cells, nickel-cadmium. I've disposed of them, but to give you a sense of proportion, here's a AA alkaline cell, and there was one arranged like this, there was one arranged like this, there was one arranged over here, and where was the fourth one? Where was the fourth? The fourth one was over here, and they were all corroded. They were leaking like hars, and when I first opened it up, I thought, okay, this is it. It's beyond repair. Well, I pulled them out, and I gave the circuit board a soaking, and used some solder flux to clean off the oxidation, and then I cleaned the board as best I could with swabs here and isopropyl alcohol. I did not get rid of all the blue oxide that's there. I also took the liberty of recapping this circuit board. There are 4 electrolytics, one here, one here, one here, one here. It turns out that when I took them out and threw them on the meter, here we go, threw them on the meter, they were actually okay. The ESR was a little high, about 2 ohms or so, but owing to the fact that those electrolytic capacitors were about 35 years old, I figured let's just get rid of them. So where we stand right now, I have done, other than the cleanup, I've done no remediation work to the circuitry. All I've done is I've replaced the capacitors and have done a cleanup of all the oxidation. The game plan is going to be to continue to fix this without restoring the NiCad batteries. Would have no use for this in a battery portable mode, that sort of thing. These plunger switches, they actually look pretty clean. They look pretty good, and before I get done, I will squirt them with contact cleaner, but they actually look pretty good, and the contacts seem to be clean just as it is. This down here is a broken, it's either a potentiometer or, what's more probable, is a variable capacitor used for fine-tuning this 10 megahertz crystal oscillator circuit that's right here. Well, why don't we begin by dissecting what we have, and then we're going to do some voltage tests to see if the power supply is sending the proper voltages to the integrated circuits, and there are 4 of them, 1, 2, 3, and 4. So what do we have? Well, let me turn it this way first. This here is the heart of the beast. This here is an intersil frequency meter chip that is nominally 10 megahertz. So what the rest of this stuff is over here is basically taking signals that are greater than 10 megahertz, conditioning them down to a frequency that this chip can deal with. Well, what does this chip do? This chip in the 1980s was in the midst of large-scale integration. In the late 1960s, early 1970s, integrated circuits were coming out in simple gate form. The Texas Instruments 7400 series of transistor logic gates. You had the CMOS 4000 series, which were low power versions of the 7400s. But in the 1970s, you started getting these rather large integrated circuit with complex functions that you could buy as a monolithic chip from companies like Analog Devices and, in this case, Intersil. So what I'm going to do is look up the data sheet for this Intersil piece right here. But what this piece does is several functions. First of all, it does the driver for the oscillator circuit, the 10 megahertz oscillator circuit. This here is a simple quartz crystal, cut much like a Citizens Band quartz crystal. But it also handles the counting, meaning that as the pulses come in, it is accumulating the pulses, converting them into binary coded decimal. And then it also has the logic for strobing the 7-segment LED digits over here. So what I'm going to do is I'm going to pull up the data sheet on this beast. And then we're also going to pull up the data sheet for each of these other integrated circuits here. There is a 7400 series, which is this one right here. This is a 74196. And these two I do not recognize, so we're going to have to look these up. And when we come back, we're going to look at the data sheets.